Let's travel to the first half of the 1940s to discover the story of an Italian power plant, the Isotta Fraschini Zeta, an engine born from a strategic need and the turbulent war years. The Isotta Fraschini Company, founded in Milan in 1900 by Cesare Isotta and Vincenzo Fraschini, had a long history of producing automobiles and, starting in 1911, aircraft engines. After facing financial difficulties in the 1930s, it was acquired in 1932 by the Italian aircraft manufacturer Caproni, which continued and even encouraged the production of vehicles and engines. In 1939, Italy faced the need to develop high-powered inline engines capable of competing with the most advanced foreign engines, such as the Rolls-Royce Merlin and the Daimler-Benz DB601. At the time, the Italian Air Ministry was working on the import and licensed production of German Daimler-Benz engines, as we have already seen. Isotta Fraschini decided to take action, attempting to design a domestic engine that could compete with, or even replace, German engines if supplies were insufficient. Fiat also attempted this approach with the A.40 RC 20-40 and a .44 RC 15-45 projects, both of which are very interesting and will likely be seen next year. Narrator. To accelerate development. The Isotta Fraschini Design Office adopted an ingenious solution, coupling two pre-existing engines. Specifically, two traditional Isotta Fraschini Gamma RC.15 engines, each producing 540 horsepower, were combined. The result was a 24-cylinder engine arranged in a 90 degrees by, an architecture that offered the advantages of air cooling and a single crankshaft, simplifying the overall design. The new engine was designated IF Zeta RC.35. This engine inherited the Gamma's 125 mm bore and 130 mm stroke. Its total displacement was 38.3 liters. On paper, the Zeta RC.35 version was expected to deliver a whopping 1,150 horsepower at 2,700 revolutions per minute. Initial estimates for another version predicted a power output of 1,255 horsepower. If we take a closer look at the engineering of this engine, we realize that the Isotta Fraschini Zeta consisted of an aluminum crankcase with 4-cylinder banks, each with 6 cylinders, arranged at 90 degrees to each other. Each cylinder was air-cooled and had 2 spark plugs, powered by magnetos located at the rear of the bank. The engine used a double overhead camshaft (DOHC) system for each cylinder bank, with one shaft directly driving the exhaust cams and a short transverse shaft driving the intake cams. The crankshaft was supported by 7 plain bearings. An interesting detail is that each connecting rod served 4 cylinders, via a master rod and 3 articulated rods. All engine accessories were rear-driven, including the magnetos, which were oversized, making them ready for high-altitude development. Also rear-driven were the vertical camshafts and a single-stage mechanical supercharger. Compressed air was routed through intake manifolds between the upper and lower V's of the cylinders, while exhaust gases were expelled from individual exhausts between the left and right verses. The engine used a pressurized air starter system and had a compression ratio of 6.5 to 1. Its approximate dimensions were 1.73 meters long, 1 meter wide and 1 meter high, with a weight of approximately 760 kilograms. Despite its promising engineering, the Zeta's development was anything but straightforward. The first run of the Zeta RC.45 took place on February 28, 1941. But the process was slowed by various design issues. The greatest challenge, as expected at Isotta, was air cooling, particularly for the rear cylinders, which did not receive sufficient airflow. This overheating problem became apparent immediately and was not satisfactorily resolved. As a result, the engine never passed homologation tests and struggled to reach its projected power output. With actual output of approximately 1,085 horsepower instead of the expected 1,255 horsepower. Several versions of the Zeta engine were developed, although many remained at the design stage. Zeta RC.35. The first design produced 1,150 horsepower. Zeta RC.40, RC 22/50, RC 15/45, RC.42, RC.50 OSD, RC 21/60, all remained at the design stage, with specific power outputs and intended uses. For example, the 1,255 horsepower Zeta RC42 version was intended for the Caproni CA.331B Raffica. The Zeta RC21/60 for the SAI Ambrosini 403 fighter, and the Zeta RC50SD for the SAI Ambrosini 404 bomber. Zeta RC.45, intended for the Caproni Vizzola F6Z fighter. Zeta RC25/60, equipped with a double supercharger, it produced 1,250 horsepower. This was the version planned for the fit G55E Reggiane Re.2004 fighters and for the Caproni Vizzola FZ6 development. Despite the problems, the Isotta Fraschini Zeta was considered for use on several aircraft. The best known was the Caproni Vizzola F6Z, or F6MZ. This fighter, derived from the earlier F4 and later the F6M, was designed to use the Zeta RC.35 engine. The decision by Caproni, also owner of Isotta Fraschini, to re-engine the F6 with the Zeta was made to overcome German engine supply difficulties. The first prototype of the F6MZ, military serial MM.498, was completed in July 1943 and made its maiden flight at Vizzola Ticino on August 14, 1943, flown by test pilot Antonio Moda. It was hoped that with the Zeta RC.35 engine, the F6 would be able to compete with the F6MZ. 35. The F6MZ could reach a maximum speed of 630 km per hour during testing. The new engine immediately showed chronic overheating problems. Flight activity was limited to a few overflights of the airport before the prototype was temporarily shelved. These problems could have been overcome with new airflow ducting and a new flare, which were being installed, but the armistice halted all experimental activity. The workers even dismantled and concealed the aircraft to prevent its requisition by the Germans. Another important project involving the Zeta was the Reggiane Re.2004. In October 1941, the Regia Aeronautica asked Officen Mechanische Reggiane, also owned by Caproni, to develop a version of their Re.2005 Sagittario fighter equipped with the IF engine, Zeta RC 24/60. This was an attempt to evade the tight supply schedule for the German Daimler-Benz DB605 engines and their Fiat 1050 RC.58i counterpart. A mock-up of the Zeta engine, actually a real engine assembly, but internally incomplete, was sent to Officen Reggiane and tested in a wind tunnel. Subsequently, to test aerodynamic compatibility and study the cowlings, exhausts, and air intakes. This mock-up was installed centrally on a Savoia Marchetti S-79 Sparviero bomber. The configuration of these parts was different from that used on the F-6Z. The Reggiane's cowling, although larger in diameter, was considered cleaner in design. Here too, cooling air was drawn from the area around the propeller nose and expelled through an annular slot in the rear of the cowling. An oil radiator was located under the cowling. However, the engine was never approved due to development delays, mainly due to cooling difficulties as mentioned. At the time of the armistice, no complete Zeta RC 24/60 engine had reached Officer Reggiane to be installed in the two fighter prototypes ordered. The Re.2004 would have had an estimated speed of 620 km per hour, about 58 km per hour slower than the Re.2005. In addition to these two, the IF Zeta engine was considered for powering other aircraft, but none were ever actually equipped with it. These included the Fiat G55, the Caproni CA.331B Raffica twin-engine fighter, the SAI Ambrosini 403 light fighter, and the SAI Ambrosini 404 four-engine heavy bomber. Following the Zeta's example, the Isotta Fraschini engineering department decided to develop an even more powerful engine, known as the IF Sigma RC 20-50 program. This too was a 24-cylinder, air-cooled X engine, born from the mating of two IF Delta RC 35i engines, each producing 730 horsepower. On paper, the Sigma was supposed to deliver a whopping 1,600 horsepower at 2,400 revolutions per minute. Its estimated dimensions were 2.08 meters long and 1.15 meters wide and high, with a weight of approximately 980 kilograms. However, I have conflicting information about the Sigma, until recently. It seemed to have remained on paper, but I have found evidence of parts of the engine in Germany. So at this time I cannot say whether certain components were simply built for testing or whether the entire engine was built. I want to conclude this video by saying that the Isotta Fraschini Zeta is a fascinating example of an engine that, born from the need for national autonomy and power, encountered complex engineering problems and the reality of a conflict that prevented the necessary development and fine-tuning. Similar engines in other nations required 8 to 10 years to bring them to operational reliability, and all faced serious overheating problems like the Isotta Fraschini. None of the examples of the IF engine were successful. Zeta built survived World War II. Too bad. I wanted to examine it up close. Have a good day.